Hello, welcome to Lesson 5, Combining Like Terms. Today, we are going to practice the skill of combining terms when they contain the same variable and the same exponent. Before we begin, let's look at our key vocabulary words. Terms, parts in an expression that are added or subtracted. Like terms, terms that have the same variable and exponent. Equivalent expression just means that the expressions are equal. Simplify means to put in simplest form, reduce, or combine. So, before we begin, let's look at two rules that are very important when combining like terms. The first rule is when you see any variable, it really has a 1 in front of it. So x would simply have a 1 in front of it. It has an imaginary coefficient of 1. The next rule that I'd like to introduce you to is that any variable alone also is raised to the first power. So x is also x to the first power. So those are two important rules when combining like terms. X is equal to 1x, and x is also equal to x raised to the first power. Okay, so combining like terms is an easy skill once you get the hang of it. So let's start off fairly simple. Okay, so if we had 3x plus 2x, all right, they both possess the variable x, and also it's raised to the first power. So all we have to do when you have like terms is to look at the coefficient in front of the variable and do the math symbol. So we are saying 3 plus 2 is 5. And then we simply let the x hang out at the end. So 3x plus 2x is equal to 5x. Okay, so all of your problems won't always be this simple. So let's step it up a notch. And let's say we have 5y plus 4 minus 6y plus z. Okay, so now we have 1, 2, 3, 4. We have 4 terms. Terms are separated by a plus or a minus sign. So let me show you that again. 1 term, 2 term, 3 terms, 4 terms. Again, terms are separated by a plus or a minus sign. All right, so what we're going to do is we're going to scan through this expression and we're going to see if we can simplify it. And I can tell right off that we have a 5y that can be joined with this minus 6y. I wouldn't say 5 plus 6 is 11. I would look at the math symbol in front of the 6y. So 5 minus 6 is negative 1. So we just now combined our like terms. And actually, in this expression, those are the only two like terms. 4 does not have a variable, and there are no more z's in this expression. So when you cannot combine anything else, you simply drop those terms down into your answer. So we have a negative y plus 4 plus z. And I want to show you something. We can flip these terms around. Negative y plus z plus 4. That says the same thing. If I wanted, I could bring the 4 up front and say 4 minus y plus z. So you can manipulate the terms in your expression, but make sure if it's a negative y, it has a minus sign in front of it. If it's a plus z, it is a positive z when you change it around. Okay? So the hint that I want to give you is when you see like terms, let's put a shape around them. Okay? Let's practice some more. All right? How about 9z plus 10x minus 8z plus 11x. Okay, so we have 4 terms again in this problem. 1, 2, 3, 4. And we're going to combine our like terms. So I'm going to put a heart around my z's. So I'm going to scan down, and here's another z. I'll put triangles around my x's. So it's very helpful to put your like terms in the same shape, okay? So 9 minus 8. Again, look, I I always take notice of the math symbol in front of the term that we are joining. So 9 minus 8 is 1. Do I really need that 1 in front of that variable? No. But to keep things simple, right now I'll leave him there, and then we'll make it look a little bit prettier at the end. All right, so 10x plus 11x. Again, I'll look at the math symbol in front of the term that we are combining. 10 plus 11 is 21. And notice, since it's a positive 21, I put plus 21. So my final answer is best written this way, okay? Z plus 21x. And remember, we can trade places. 21x plus z. Since it's a positive z, we add it. Okay, so I hope you're following along, and I hope this is fairly simple for you. So far, we haven't had any exponents other than the imaginary 1. So let's try some that have some other exponents other than 1. So look, x to the second power plus x to the third, okay? They all have the same variable, but however, they do not have the same exponent. So we can't join any of these terms. So we could simply write cannot combine, and your teachers would probably accept that. If you're doing a little homework paper assignment, or maybe if it's on a computer, they would probably just repeat the problem, okay? The expression. They would just drop down the same expression, and notice I put it in ascending order according to the exponents, x to the first power plus x to the second plus x to the third. But remember, you can always change places whenever you are dealing with combining like terms. All right, so let's keep going. All right, let's try another one that has, let's try one with 6 terms this time. Okay, so 4 plus a minus b plus 5b minus 17a, 1, 2, 3, 4, 5, plus 7. Okay, so we have 6 terms. 1 term, 2 term, 3 terms, 4 terms, 5 terms, 6 terms. So what we're going to do is we're going to come through our expression and we are going to put a shape around the like terms. Okay, 4 is a constant. Do you see any other constants in this problem? And I do. All the way down here on the end, the 7. So 4 and 7 are like terms. They do not have variables. They are simply constants. So I could join my 4 and 7. I'm going to go ahead and do that. 4 plus 7 is 11. What could I join with my a? Remember, it's 1a. And I'll scan, and I can join the negative 17a with it. So think about that. 1 minus 17 would be a negative 16. So I would just write minus 16a. When I drop that down into my answer, it's a negative 16. So I'm just going to write minus 16a. And we'll just put a triangle around our b's. So we have a negative b, which is a negative 1, plus a positive 5. So negative 1 plus 5 is a positive 4. And since it's positive, we'll say plus 4b. So look at our answer, 11 minus 16a plus 4b. Sometimes the best way to arrange your answer is to put it in alphabetical order, okay? So I could put negative 16a plus 4b plus 11. Does that represent the same expression? And it absolutely does. Negative 16a, it's still negative 16a. Positive 11, positive 11. Positive 4b, positive 4b. So that's the best way to write the answer to that expression. All right, let's try a few more. Again, this is a simple lesson, combining like terms. Remember the rules. If it's a variable by itself, it really has a 1 in front of it, and it also has an imaginary exponent of 1. All right, so let's try m minus m squared plus 4 minus 6a plus 10a. Okay, so this time I have 1, 2, 3, 4, 5. I have 5 terms. Can I join these two m's? No, I cannot, because they do not have the same exponent. So whenever I'm bringing my terms down for my final answer, I'll just drop them down. They'll stay separated because they do not have the same exponent. Can I join 4 with anything? No. So I just drop 4 down. And then the only two like terms would be this negative 6a and the positive 10a. So do your integer rule. Negative 6 plus 10 would be a positive 4. Since it's a positive 4, you simply add 4a. Again, we can manipulate the terms, and let's put them in ABC order. So positive 4a up front, and then I could put plus m minus m squared plus 4. Could I also write it like this? Absolutely. So make sure whatever sign is in front of the term is represented whenever you switch the terms around. All right, we'll finish with one more. All right, how about 11x plus 10y minus 4x plus 21y minus 9. All right, how many terms do we have in this expression? 1, 2, 3, 4, 5. Our like terms, I'll put my x's in circles. 11 minus 4 is 7. I'll put my y's in hearts. 10 plus 21 is 31. And 9 does not have anything to join with. So we drop it down until our, with our final expression. So hopefully you feel confident in your ability to combine like terms, and I'll see you in lesson 6.